particular methodology primarily focusing on reducing time with within the production system as well as a supplier and to the customer. So when the product is needed in a quickly manner or in a timely manner, in a just in time, it should be a very much risky when it is not adequately or properly implemented in case of organizations. So if you go to the just-in-time concept, as you know, the just-in-time, which includes zero inventory, zero lead times, the next is zero delay, the next is zero failures. So these are the prime focus, which is reduce the time in case of within the production system as well as supplier and the customers. The next part is we have already discussed in case of your objective of just-in-time to be more responsive towards customers or to the customers. The next is better communications among department, sub-department, supply levels, and it is very much flexible within the organizations and achieve better quality as far as concerned with product and services and reduce the product cost. So these are the basic objective as far as concerned with just-in-time concept. The next is the philosophy, or you can say that is the principle, that is elimination of waste. The next part is continuous improvement. The next is quality at different source levels. Then simplification of process or production system, visual control of your production system, focus on customers' need, and the next one is production to the customer demand, respect for individuals. So these are the basic philosophy which is included in case of your just-in-time concept. The next, the most important thing, the next one is the element of just-in-time concept, which is directly focused on smooth of flow of work, then elimination of waste in various part of your production systems, then continuous improvement when the cause and error or any kind of difficulty faced by the production systems. The next is elimination anything which does not add value to the product. Then simple system and easy to manage the just-in-time concept. Use of product layout to minimize the work flow or moving material from one part to other part. And the lastly, quality or quality management implement in case of just-in-time. So apart from those things, in the previous class, we have discussed design and improvement aspect of just-in-time concept. So as you know, we have already discussed the housekeeping in the form of physical organization, the discipline. In that scenario, we have discussed the investment in case of design system, which is directly implemented in case of layout design, product layout, process layout, arrangement of machines, tools, and equipments. The next part is a lot that all the lot strategy provide concept in just in time that see if in the smallest increment is possible. If you not go for the larger, because the larger to plan to invest in case why the lots each particular things. The next is streamlining movement and smoothing the metal handling. That if you different kind of software or floor, in that case out of vehicles. Next is articulate robot to minimize the work handling materials as well as the different type of or you can say that is smoothing the material removal. And I think the most important thing in case of movement directly your in case of the team who is responsible for design the part and complex project, use of by the kind of software or names a more product similar in case of material movement from one place to other place. And the lastly, they in case of just in time and implement the pool system or final Kanban system. We are all today we discuss the particular Kanban signal system, how more provide on activities and when the team back and use of software. As you know, today topic, the next topic is or today topic is known as your 7 waste. So in case of Seven waste is only originated World War II in case of Japan, where the more number of specialization is concerned. The waste is known as Muda in case of Japanese word. So there are 7 waste is a particular tool for categorize Muda, and originally developed by Toyota chief engineer T.I.H. Who is the core of the Toyota production system. The T.I.H. Who has developed the concept of 7 waste, which is also known as your lean manufacturing. To eliminate the waste, it is important to understand exactly what the waste is and where it exists, and while the product significantly differ between factories. The typically waste found in manufacturing environment are quite similar. In case of any kind of manufacturing industry, the waste are very much similar. For if you go to the next slide, go to the next slide. Okay. So in case of Muda, if you if you see the particular figure, in case of Muda, in case of Japanese word, that is known as waste. If you go to the first one, that is overproduction. The next one is inventory. The third one is waiting. The fourth one is motion. The fifth is transportation. The sixth one is overprocessing, and the last one is overproduction. The first one is overproduction. Produce faster in higher quantity than the customer demand, and that directly overproduction is directly belong to involve more amount of value addition in case of storing, loading only activity, and other related activities which is directly concerned about overproduction. But in next one is your inventory, the raw work in progress and finished good which is not having value added to maintain a higher amount of stock, that also need some space, some warehouse, some storing space, loading already activities. Next is advice for waste tools or 7 waste methodology, which is introduced by TH who directly suggests you have to maintain an adequate level of your inventory. The next is waiting, the people and parts that wait for a work cycle to be completed. We have to minimize the waiting cycle of part people who are directly involved in case of number of workstations. The next one is motion, unnecessary movement of people, parts, and machine within the process. So whenever you assign a particular person, that person is dislike the different process activities and move from one place to other place, that directly hamper the production activities. So as far as concern with the manufacturing activities, when a person is not strictly involve himself in the manufacturing activities, and due to his lack involvement in case of workstations, they generate more amount of wastage in case of delay, in case of machine setup, in case of running the machine, in case of maintenance. The next part is transportations, unnecessary movement of people or part between processes. So as far as concerned, as you know, this particular things is directly concerned with the waste. Whenever when you are not employed any kind of automated guide vehicles or any articulate robot for movement of people or movement of material from one workstation to other workstations, they directly generate a few amount, or you can say some, in case of some industry, it will generate a higher amount of wastage during transportation activities. The next is, if any kind of difficulty found in case of production activities, which directly go to defect. That defect is directly rework in case of steel organization, in some metal organizations. And the rework in the form of steel organization, that is known as remelt. And that remelt added some value, that value would be included in case of product cost. So if you not write or first time and repetition and correction of process in the form of rework, that increase the percentage of wastage in case of rework of that particular product. The last one is over processing. It also include the processing beyond the standard required by the customers. So that is where the 7 waste tool suggests there are some international standard or SOP should be adopted by the company for good manufacturing practice, and due to that adoption of good manufacturing practice, they made the products in a standardized way, and they reduce the percentage of over processings. So these are the things we are discussed one by one in the previous slide. Sorry, in the next slide. Go to the next slide. Okay, we have already discussed. The first one is overproduction, waiting, then transportation, inappropriate processing, unnecessary inventory, unnecessary or excess motion, and the last one is defect. Going to the next slide. Okay. So in case of productions, if you see that thing over high costly to a particular manufacturing plant because it prohibited smooth flow till actual degrade quality and productivities. So when the Toyota production system is also refers just in time concept, every item is made just as it is needed. Overproduction referred to just in case. So due to that, create excessive lead times, result in high storage cost, make it to detect defect. And next point is simple solution to overproduction is turning off the tap. This requires a lot of courage because the problems that overproduction is hiding will be revealed. So this concept is to schedule and produce only what you immediately sold to improve machine setup and capacity. So due to overproduction, what will happen that in the excess result high storage cost and make more defect in case of product qualities. So due to that thing, you have to go for or go to a remedy like schedule and produce what immediately need and sold, and you must go for the machine changeover if any kind of difficulty occur in the workflow levels. You have to go for setting the capability of machines. Next one is time. As far as concerned with the time, whenever goods are moved or processed, the waste for waiting occurs. Typically, more than 9 product lives in a traditional batch or few minutes will be spent waiting to the process. That is why if you go to the company, they made the arrangement of more number of buffer to reduce the time of waiting. The next point is much of product lead time is tie off in case of waiting for the next operation. This is usually because the material flow is poor and production runs are too long and distance between work centers are too great. So due to proper arrangement of a layout, you have to place the more number of workstation which is nearer to the next sequence level of workstations. So due to that thing, you can minimize the uh, material flow from one workstation to other workstations and minimize the distance also, and also affect the lead time also. So if you minimize the lead times, the workflow, and the distance between number of work center, it directly affect your waiting. The next is, as you know, in case of theory of constant, this is a particular concept is given by Eliyahu Godra. He stated that many times 1 hour in case of lost in case of bottleneck process in 1 hour lost to the entire factory output. So if you have arranged 4 to 5 number of workstation in a sequence manner, if the machine number 2 faces any kind of difficulties, for example, in case of 1 hour, that machine is lost, that breakdown will affect to the entire factory output. So if that machine is get breakdown, the all improvements and maintenance work will directly goes to that particular part, and they help to smooth that particular machine in a such way that the raw material flow should be smooth and that should be passed from one workstation to other workstation. What he suggests. That means go to previous one, previous slide. Okay. He suggests that linking the number of workstation or linking the process together that can be fed directly into next dramatically reduce the waiting time. So whenever you face any kind of difficulty in case of arrange number of works, or if you arrange a 4 to 5 number workstation and the workstation number 5 got any kind of maintenance difficulty, that whole team attend that difficulty in the form of maintenance and smooth the machining and smooth the material flow. That that product should be passed from one workstation to other workstation in that area. That is the concept they have given of concept. the constant theory of constant, and buffer will be all the teams to attach to and effort to smooth that particular operation or message. Moving to the next slide. The next transport is in case transporting production processes is cost carrying in case no value particular movement and for quality movement of and long distance due to improper arrangement of layout of machines. The material handle must use to transport material and the resulting another organization cost that add no more. So this particular transporting, so whenever you arrange improper layout of machines, equipments, tool, the movement is very much higher. So to that machine setup and machine running time should be directly affect the time of particular process. No particular should be added in case of transportation. But this would be due to think that transportation can be difficult to reduce due to cost moving process close together. That is why of transportation they suggest you have to arrange the more number of machines that they get attached together in a such way that you can minimize the cost of transportation or cost of moving components from one workstation to other workstation. So further, it is often hard to determine which process should next to each other. Mapping product flow can be easier to visualize. That is why it is advised by the advice to the operational activities. They should implement the product flow mapping or product flow map. By the help of product flow map, they can easily visualize and track the activities of number of workstation or even number of people who are directly involved in case of manufacturing activities. Moving to the next slide. Next slide. Then inappropriate processings. Often the term using sledgehammer to crack the nut. Many organizations use expensive high precision equipment, but the simpler tool would be sufficient. So due to rapid demand in case from customer point of view, nowadays some numerical control machines should be employed in case of, if you take the example of in case of automotive industries. So due to that thing, what will happen? It is difficult to arrange, rearrange, and make a particular setup of those high precision equipments. So this is often you can do this particular thing by the help of a simple tools also. So this is often result poor plant layout because preceding of sequence operation are located far apart. So in addition, they are encourage high asset utilization, that is known as overproduction with minimal changeover. So whenever a demand is occur, you have to need for the changeover in case of machine setup. So in order to recover the high cost of this equipment is very much essential, which is which is count in case of waste. That is why the Toyota is very much famous. They use low cost automation and combined with immaculately maintain often older machines. They invest in smaller and more flexible equipment where possible. So if you go to organization point of view, in case of material handling and raw material shifting and loading organic activities, most of the company are use very simple and flexible machine. And the machine for loading and unloading activities that is known as automated guided vehicles. Even if they use conveyor, so even a belt in case of loading and unloading activities. So these things provide more flexible in case of equipment where it is possible. The creating manufacturing cells combine step with greater and reduce the waste of input. So by implementing articulate robot, by implementing automated guide vehicles, even material conveyor or conveyor belt, you can reduce the waste of input processing by sequentially arrange different type of workstations. Moving to the next one. The next is unnecessary inventory. So in case of work in progress, as is a directly result of overproduction and waiting, The excess inventory tends to hide problem on plant floor, so which must be identified and resolved in order to improve operating performance. The next is excess inventory increase lead time and consume productive floor space, delay in case of identification of problem and inhibits the communications. And by achieving seamless flow between workstation, many manufacturers have able to improve customer service, slash the inventory, or you can say that is optimize the inventory levels and their associated cost. So if you hire a huge amount of inventory, they directly go to work in progress, and it is directly hamper the operating performance. So if any kind of you can say that is it also increase the uh, different aspect of good manufacturing practice. So for example, in case of lead time, it also occupied the floor space, and delay in case of identification of, and in case of improper communications that lead to unnecessary inventory level. So it is the advice through the 7 waste implementations. You have to achieving the seamless flow of work center in many manufacturer that's able to improve the customer service, because they in case of company point of view, they just optimize the inventory level and what are the costs directly associated with the inventory level. The next one is unnecessary or excess motion. So this waste is related to ergonomics, that is the study of people efficient in their working environment. It is instead of stretching, walking, lifting, and these things. So that is why motion study, or you can say that is thoroughly should be implemented to track and visualize control of those people who are directly involved in case of number of workstations. There are also we can say that health and safety issues is concern, which is today's litigious society for becoming more problem for the organization. So due to job with excessive motion, that should be analyzed and redesigned for improvement with the involvement of plant personnel. And it is the duty of HR department. They provide adequate training regarding ISO 18000, which is directly related to health and safety issues, which it is an international standard which is implemented for health and occupational safety of people who are directly involved in case of organization. That is why another method that is known as Thurbelis. As you know, in case of Thurbelis, there are 18 number of symbol should be used, and that symbol will be easily analyzed and tracking through the different camera surveillance or CCTV surveillance, and if any kind of difficulties which occur, that should be easily resolved, and and an improvement should be implemented for resolve those kind of problems in case of motion or excess motion study. And the last one is defect. So in case of defect, the direct impact to the bottom line. So in case of bottom line, the quality defect resulting rework on scrap. So as I told, in case of steel industry, if any kind of a difficulty occur regarding qualities, they directly goes to the scrap, and that scrap is again remelt, and in case of remelt, some value are added, which that value which should be included in case of product cost. So as far as concerned with the rework and scrap are tremendous cost to the organizations, and associated costs including uh, quarantining, inventory, reinspection, rescheduling, and logistical costs. So in many organizations, the total cost is of significant total cost. So through the employment and improvement process that is known as CPI, there is a opportunity to reduce the defect. That is why companies providing more number of adequate inventory or optimize inventory level, re-inspect the quality, and then reschedule the things, and then if you go for the arrangement of quality, minimize the defect in many facilities which is concerned with good manufacturing practice. Moving to the slide. Next. Okay. The next one is your Kanban system. If you have any doubt regarding the 7 ways, you can ask the questions. Anyone? Yes, anyone have any questions regarding 7 waste? You can also drop your question in chat box. That after the class, we'll discuss the questions related to the present topic. Okay, fine. The next one is Kanban system and the definition and principles. So as you know, the Kanban is literally a signboard or billboard in case of Japanese word. It's a particular scheduling system for lean and just-in-time productions. The Kanban is a system to control the logistical chain from a production point of view, and it is an inventory control systems. So as far as concerned with the Kanban system, it's a typical signboard who contain all kind of specification related to machine specification, load, unloading activities, capacities, all the things should be written in a signboard. And when it is also schedule system for your lean manufacturing or lean production system as well as your just-in-time production systems. So this Kanban was also developed by T.I. Hu, an industrial engineer, as far as concerned with the Toyota production system. It's a system to improve the maintain high level of production. The Kanban is basically implemented for high level of productions. Moving to the next slide. The next one is Kanban system. In case of Kanban method system, the Kanban method is an approach to incremental and evolutionary process and system change the organizations. So it uses work in progress limited to pool system as the core mechanism to expose system operation or process the problem and stimulate collaboration to continuous improvement the system. That is why through those signal and you can say the display Kanban systems, you can use the pool system as a core mechanism to expose the system operation problem, especially in case of process. And it is a collaboration to continuous improvement of the particular systems. So it is basically a visualization of an important aspect of Kanban. It allows to understand the work and the workflow of material from one workstation to other, also especially in case of your shop floor. Moving to the next slide. So here the basic idea regarding your Kanban. If you go to the customer log on order, is an ordering system is there. And from customer, the order system in the form of demand information reach up to the order information, then order information to the suppliers. So here supplier pulls the order into the produce to the particular order, and in the step 3, the supplier deliver exactly what the customer ordered. So that means that flow of order should be displayed in the form of Kanban system. First, the customer provide the order information to the supplier, and supplier provide the order. The flow of that particular arrow starting from customer point of view, customer to the order information, then order information to the supplier, and supplier to the customer's levels. So this is the wide, I can say that is the simple example of your Kanban system that display how the order should be passed from the arise from customer point of view, and it should be reached to supplier, and how supplier will be provide the delivery exactly what the customer is ordered. Moving to the next slide. Next slide. Okay, so these are the basic principles as far as concerned with the Kanban system, starting with the existing process. And the Kanban method does not prescribe a specific set of rule or process step. As you know, this is a particular signal or signboard. The Kanban method start with the existing rule and process, and you can stimulate continuous and incremental and evolutionary change to the particular system. So this next one is the Kanban method is change management methods. The next is agree to pursue incremental and evolutionary change, respect the current process, role and responsibility and titles. And the next one is leadership at all levels. The next is act of leadership at all level in the organization, from individual contributor to the senior management are encouraged. So here this particular principle is start with the existing process, not describe any set of rule or process step. It exists the role and process and stimulate the continuous improvement to the particular process. Agree, pursue incremental and evolutionary change for the process. respect current process, role, responsibility, and title of the particular job. And it required all kind of leadership at all levels. Act at leadership at all level of organizations, and individual contributor to the senior management are encouraged. So these are the basic principle of Kanban system. Moving to the next one. Next slide. Yes. So if you take the example of supermarket in the form of Kanban, here the first one is customer select the particular product, then the executive is check out, the clerk scan the particular product and send to the computer signal warehouse, then computer signal warehouse to the regional warehouse, then regional warehouse to the truck replace, large variety, then the sell stock, ready value should be reach up to the next warehouse where this customer can be received. So this is a typical example for Kanban scheduling of supermarket. When a customer provide the order, the clerk should be scan and check the order, then directly sent to the computer signal warehouse where right volume, uh, right volume or regional warehouse should be responsible. They can directly transport a particular product through large variety, sales stock, and ready values. They should be reached up to the distribution outlet where the particular product would be given. So this arrow starting from the go to previous one. Go to previous one. So this arrow starting from the customers selection, it should be provide the mapping you can say the process mapping of demand, start from the customer to the clerk, then the clerk sent to the regional warehouse, the regional warehouse through the logistic activities should be reached up to the outlet and fulfill the demand of customers. So this signal schedule of supermarket that display in case of your signal Kanban. The next part, if you go to the Kanban system in case of manufacturing environment. So if you see there are machining operation is there, optimization for different batches, then set of machines, then common tooling is there. But in case of Kanban stock point, that segregate and that specify the different type of stock available for each item, then assembly and reassemble of items, then individual replacement is there, then signal of each withdrawal Kanban or signal of which machine should be there. That display which directly go to the final assembly and where they can be optimized for production and customer requirement. So this flow from the machining, then Kanban stock point, then lastly final assembly, this arrow directly display or represent the Kanban system in case of manufacturing environment, especially in case of assembly line. So whenever you go to any kind of industry, they provide a particular display, and that display contains the machining information, even if your Kanban stock point and finally it reach up to the final assembly point, and each assembly which specially define the product flow, the process flow, the mapping chart, the process mapping chart, even if the process atlas of the particular assemble center. Moving to the next one. The next one is your type of Kanban systems. So in a Kanban system, the workstation communicate with each other through their cards, where each container has a Kanban associated with it. The two of the most important Kanban are production type Kanban and transportation type Kanban. So as far as in the previous image you have seen in case of manufacturing Kanban, there are three number of workstation is there, and they are communicate with each other. This one, bottom one, they were communicate with each other starting from the machining, then the Kanban stock point, and the final assembly, and they produce the different. They produce what customer need in a just-in-time manner. So that is why the Kanban is implemented by the help of lean manufacturing as well as just-in-time productions. Moving to the next one. Next one. So going to the first one, the production Kanban. As you know, the production Kanban, when receive and authorize the workstation to produce a fixed amount of product. This is known as production Kanban. And the production Kanban is carried out carried one container that are associated with it. That means it contains the details of that particular product in a fixed amount in a fixed amount, and that container is associated with that particular product. That is the concept. I just repeat, the production Kanban when receive and authorize the workstation to produce the fixed amount of product, and the production Kanban is carried out on the container that associated with it. That means that display all the specification, the data, the tool, the equipment which is related to produce that fixed amount of product. Moving to the next one. So basically the production Kanban is divided into two types, that is pool type production and push type productions. So first we discuss about pool type productions. You know this particular figure contains 4 number of workstations, and starting from the delivery from the suppliers, it directly pass from workstation number 1 to 2, then 3 and 4 sequentially, and finally deliver to the customers. But the thing is that in case of production or pool production, the Kanban instruct previous process to produce including suppliers. So that is why the red color arrow indicate the previous process to produce including supplier, and a particular MRP, material requirement planning, should be scheduled. So if you go to the production Kanban in the form of pool production, as a product, it is used in each process material is drawn from the previous process through the Kanban authorities. So in case of production Kanban, as you know, the authority is assigned to produce a fixed amount of product. So that is why you must go to the previous process to produce including suppliers. That is why if you go to the last point, as the product is used in each process material is drawn from previous process through the Kanban authorities, and minimize the work in progress and finishing stock. So there is no particular buffer, and the work in progress should be occurred in between them. So due to that thing, the pool production should be carried out. And finally, the raw material which convert into final product delivered to the end customers. Moving to the next one. Next one is your post production or post Kanban. In that thing, a material planning schedule should be equally implemented in case of 4 number of workstations, and that material planning schedule directly sent to the delivery from supplier. Those who are supplier, so the supplier is responsible for delivering the raw material. They also receive the material requirement planning schedules. So according to that schedule, they must perform their manufacturing activity to produce the finished goods stock. So here the material and work in progress pushed from one process to next. So here the black color arrow indicate the raw material is received from the supplier by the workstation 1. Then it next move to the workstation number 2. Then next sequentially it move to workstation number 3, and simultaneously it moved to the workstation number 4, and finally it reached to the finished goods stock levels. So I just repeat, the material and work in progress is pushed from one process to next. Typically the large quantity of work in process in between each process, and that working process is controlled by the material requirement planning schedule. So this is known as your post production or post Kanban system. Moving to the next one. Next slide. So here the difference between push versus pull Kanban. If you go to the push side, make that is known as your make all we can just in case. In that case, the production approximation and anticipation of use and lot size and high inventory are considered. Waste is very much nominal, and then managed by fire lightning and poor communications. Just repeat, production approximation is there, anticipation of uses, large lots, high inventory, waste, management by fried, poor communication. But if you go to the pool side, make what needed, when we need it. In that case, the production is very much precision, actual consumption, small lot is included, low inventory, waste reduction, management by site, that is known as visual control, And lastly, better communication between all level of manufacturing. So these are the basic difference between pull and push Kanban system. Moving to the next slide. The next slide is transportation Kanban. In that case, a transportation Kanban authorizes the transportation of full container to the downstream workstations. The transportation Kanban is also carried out one container that are associated with transportation to move through the loop again. So what are the loop? The loop consists of different type of machines, and then transportation is directly a particular container which is associated with transportation to move through that particular loop. I will show that image in the next slide. Moving to the next slide. So here the transportation signal or transportation Kanban is tells about when to move and what to move and where to move and how much to move. And that display and signal are displayed through the signboard. Typically, if you go to the types of transportation Kanban, the customer Kanban signal is there that basically include transfer material from plant to customer. Then move the Kanban signal that transfer material between the workstation. And third one is supplier Kanban signal that is pull material from supplier to plant. Moving to the next one. Till that, do you have any doubt or you can ask me? Anyone? Any doubt from your side? You can ask. Any doubts? Okay, fine. Moving to the next one, next slide. Okay, the next one is in case of Kanban, is a scheduling system as I discussed for lean manufacturing and just-in-time manufacturing or just-in-time concept. The scientist or the philosopher in case of Kanban development, in case of industrial engineer from Toyota, the Kanban is one method to achieve the just-in-time manufacturing. This particular system takes the name from the card that track production within a factory. So this is a particular signboard or card which is implemented for achieve the just-in-time. So for many automotive sector, the Kanban is known as the Toyota nameplate system. As a such term is not used some other automakers. The Toyota, for example, the 6 simple rules and close to monitor these particular rules. That is never-ending task, thereby ensuring the Kanban does what it requires. So as far as concerned the TIG who's implemented the Kanban system for Toyota production systems, and they emphasize 6 simple rules as far as concerned with Toyota production system. So what are the rules? Moving to the next slide. Next slide. So here the Toyota has formulated 6 rules for the application of Kanban. The first rule is each process issue request to its supplier as it consumer its supplier. The next is each process produced according to the quality and the sequence of incoming requests. The third one is no item are made or transported with a request. The fourth one, the request associated with an item is the request is associated with an item is always attached to it. The fifth one, the process must send or defective items to ensure that finished product will be defect free. And the sixth one, limiting the number of pending requests make the process more sensitive and reliable inefficiency. So these are the 6 rules implemented by Toyota for achieving the just-in-time manufacturing in case of Toyota production systems. Moving to the next one. The next one is Kanban card. So in case of Kanban card is a key component of Kanban system, and they signal the need to move material within the production facility or to move material from outside supplier into the production facilities. So in case of Kanban card, in effect a message that signal depletion of product part inventories that contains the different specification of product part even if your inventory. The more production and the Kanban card signal demand for more product. So Kanban card help to create demand driven systems. The last point, it also help to lower inventory level, helping company implementing such system be more competitive. So when uncertain demand is placed by customers, so that directly the production activities or the production department is responsible for arranging Kanban card for smooth operation or smooth achieving of smooth improvement of your just-in-time manufacturing. When the part or component is needed in exact time basis. So if you see the example in case of uh, Kanban card, so there is a typical example in case of Kanban card. On the left side is known as Widal Kanban, and the
अरे सारंग का आवाज टा आସୁଥିଲା हेलो हेलो
सर ना ना ମୁଁ ସେଇଠି ବି ଥରେ ଜଏନ୍ କଲି ମାନେ
ମତେ ଲାଗିଲା କି ମୋର ବୋଧେ ଖାଲି ନେଟୱାର୍କ ଇସୁ ନା କଣ
सर का आवाज ही आସୁନି ଟୋଟାଲି ସର ତ ଲେଫ୍ଟ ବି ହେଇଗଲେ अबे सर ଯେତେବେଳେ ପଚାରୁଛନ୍ତି ଗୋଟେ yes କି no କହିବା ପାଇଁ ବୁଝିଲା କି ନାହିଁ ମତେ वापस ଆସିବାକୁ ପଡୁଛି ଗୋଟେ କି yes କି no କହିଦଉନୁ କଣ ପାଇଁ
ହଉ ଏଥର କହିଦବା
ହଁ ମୁଁ वापस କାହିଁକି ସ୍କ୍ରିନ୍ କୁ ଆସିବି म्यूट କରିଦଉଛି ନା ମାଇକ୍ ଟା ଆଟଲିଷ୍ଟ କିଏ ଗୋଟେ କହିଦିଅ yes या no ହିଁ ତ କହିବାର ଅଛି
କ୍ଲାସ୍ ହବନି ସାର୍ କହିଲେ ଫୋନ୍ କରିଥିଲେ କ୍ଲାସ୍ ହବନି ସାର୍ଙ୍କର କ'ଣ ସଡନ୍ ହେଇଗଲା ଲ୍ୟାପଟପ୍ କ'ଣ ପ୍ରୋବ୍ଲେମ୍ ଅଛି ତ ହବନି ସାର୍ କଲ୍ କରିଥିଲେ କହିଲେ
ସଡନ୍ ଡେଥ୍ ହେଇଗଲା କ'ଣ
ଆବେ ସଟଡାଉନ୍ ହେଇଗଲା
ରେକର୍ଡିଂ ସେଣ୍ଡ ହବନି ଟେନସନ ନେନା ସେ ରେକର୍ଡିଂ କ୍ୟାନ୍ସଲ ହେଇଯିବ ଆପେ ଆପେ
ହଉ କ୍ଲାସ୍ ହବନି ତ ଛାଡ଼
ହଉ ଚलो ଗୁଡ୍ ନାଇଟ୍
ନମସ୍କାର
ନମସ୍କାର
ଆପଣ ମାନେ ଖୁସି ତ
बहुत बहुत
सब
खुशी
आने खुशी बहुत खुशी अब ये तुम लोग के सबटाइटल्स दिख रहे हैं
मतलब
पता नहीं जो जो बोल रहा है ना उन सबके सबटाइटल्स नजर आ रहा है मेरे को
अरे वो भी क्या अजब अजब से मतलब आ रहा है बुटाने फुटाने लिख रहा है बे अरबिक अरबिक अरबिक
अरबिक
अरे अगर सिर्फ इंग्लिश में ही बोला जाएगा ना तभी जाके वो मतलब अरबिक 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 अरबिक
तू साला अरबिक बोल रहा वो बोल रहा है भाई क्या बोल रहा है भाई अरबिक लिख दो
पता है मैं कौन हूँ शेख कमलान कुमार साहू
अबे
एक
काका
सत्य
मेरे को
पृष्टि
बताओ
अरे
चलो चलो चलो
हाँ
ओ गुड नाइट
गुड नाइट